Hey, what's up, guys? This is Cheng here. So this time, again, today's daily challenge problem number 376. We go subsequence. Cool. So you're given like an integer of arrays, right? Integer array numbers, and we need to return the length of the longest Wiggle sequence. So Wiggle sequence is a sequence where the difference between the two adjacent numbers strictly alternate between the positive and negative. So which means that, for example, if the first one is increasing, the difference is like a positive number. So the next difference has to be a decreasing, has to be a negative number, right? So as you guys can see here, that's why for the first one, the entire array is like Wiggle sub a sequence, right? And then that's why uh, the answer for this one is 6, right? Yeah, and then for the second one, there's another options here. And so keep in mind that we're looking for a subsequence. It's not like a continuous like subarray. It's a subsequence. Cool. And the constraint is 1000, right? And there's a follow-up. So for this one, at the first glance, right, this one is very similar to that, uh, LIS problem, which is the longest increase subsequence, right? So the only difference for this one is that it's not increasing. It's like has to be a alternate like difference between the positive and negative. So I mean, so the naive approach, not the naive approach, but the first approach will be what? Will be, since we need to alternate between positive and negative, right? Which means we need to maintain like two DP arrays. Okay. So it means that we're gonna have like a positive and a negative, right? A negative array here. So this two DP array means that at the ith location, right? At ith location, basically from 0 to I, right? Longest Wiggle subsequence, right? Wiggle subsequence, right? So similarly for this one, right? For the positive, right? Or the negative, right? Right. So I mean, so this one, the longest Wiggle subsequence, if the last difference is positive, and this one is the longest Wiggle subsequence if the last difference is negative, right? At ith location, so that this basically the DP state transition function will be basically we're gonna loop through we're gonna have a DP, not DP, right? So we're gonna loop through from 0 to I, right? And then we have a J here, right? So and then we check if the nums I is greater than nums J, right? If that's the case, it means that okay, so for the current one, we have a positive, right? So which means we have a positive of I, right? And then it's gonna be the max of the positive of I, and then do a negative, right? So because it has to be alternate, right? So we have negative J plus 1, right? That's gonna be the first approach. Basically, it's very similar like the IIS, right? So basically, at each of the i's location, we loop through from 0 to I, and then we check if this nums I, right, is greater than nums J here, right? Else we do another one. So we have a negative one, right? So a negative I, if this nums I is smaller than nums J here, we do a negative one, right? Similar like this one. And in the end, right? In the end, we simply do a max of this two positive and the negative, right? And then we can get the final answer, right? And cool. You know what? Let's try to code that thing first. Okay. So we have a length of numbers, right? And then we have a positive. So at the beginning, everything's one, right? Because it says, a sequence with fewer than two elements is trivially a Wiggle subsequence, which means that the number by itself is a Wiggle subsequence with a length one, right? So we have a positive and then we have a negative. So also one, right? And then for I in range of 1 to n, right? And for j in range of I, right? So if the nums I is greater than the nums j, right? Then like I said, we have a dp, sorry, not dp, sorry, we have positive, right? Because that means the ending with I, right? So the last difference is a positive number. So we have positive I equals to max of positive I, right? Dot negative, right? Negative j, right? Plus one, because since the last one has to be a negative value, that's why we use a negative j plus one, right? Else if, right? Else if the numbers I smaller than the nums j, right? If that's the case, we do a negative, right? Negative I equals to max of negative I, and then we do a positive, right? J plus one. Okay. I mean, if the nums I is equal to nums j, basically nothing changes, right? Because that will not either increase or decrease. So that's why we simply just ignore that part. So in the end, we return this one, right? We return we do a max of dpi positive, right? And then we also do a max of negative. Because like I said, I think the longest one could happen at anywhere, right? I think this should work. Let me try to run this code. Okay. Yeah, so this one works. Let me try to remove this part. I want to see if I only do this one, will this work? I mean, if I only get the last one, will this one work? Let's see. Okay. All right, so this one also works basically. Yeah, so we don't have to do a max of this one because the last one either it's positive or it's negative, right? So it has to be that either one of them. So we don't need to worry about that, the previously values. Okay, cool. So for this one, as you guys can see, right? I mean, this one is like a n square time complexity, right? Because we loop through for each I, we loop through from 0 to I again, right? And then here's a follow-up, right? Can we solve this one within the O of n time? So actually, if you watch this problem closely and if you compare it a little bit more with that LIS, so the reason in the longest increase subsequence we do this kind of inner loop for j between 0 and I is because we want to make sure that the current number is greater than this number, right? And that's why, in the end, in the IIS, if you guys still remember, we have to do a max out of DP because like I said, the longest increase subsequence could end at any location. But for this one, as you guys can see, actually we don't care. We don't need to worry about the middle state. Actually, all we care is the last step, right? So actually, it give us like a hint to improve this one, basically to remove this inner loop. So the reason being is that, actually for this problem, let's say we have like some numbers here, right? And let's say we have I is here, and I minus 1 is here. Okay. Actually, all we care is these two numbers. The last two numbers, because if the nums I, right? If nums I is greater then the nums I minus 1. It means that the positive subsequent, basically the positive subsequence will always increase by 1. It doesn't really matter, right? What values, what are those values? Because all we care is we only care about this last two numbers. It doesn't really matter if this one is kind of 1 2 1 2 1 2, right? So this one, let's say it's like 199, right? It doesn't really matter as long as they are. Sorry, I think it's going to be the 99 and 100. As long as the nums I is greater than nums I minus 1, this one will give us like the increase of the positive uh, value, right? And then we can simply accumulate that to the end. Similarly for the negative one. That's why, comparing to the IIS, in the end we only need to check the last element. Cool. So what does it mean is that we can simply remove this kind of the inner loop, right? And instead we can do this. Basically, now since we're accumulating the length of each of the items here, so it means that at the beginning, we have to initiate. Basically, if we don't pick this number, right? So if we don't pick the current numbers, so both the increase and decrease number will stay the same, which means that it's going to be an increase I minus 1. This is going to be a decrease. Sorry, not increase. Okay, so I was thinking something else. So positive, positive, and then we have a negative, right? I equals to a negative I minus 1. So this two lines means that if we don't pick, that's the base case, right? If we don't pick it, we still have the length from the previous state, right? And then here, right? So and if the current one is greater than the I minus 1, right? It means that the positive has one more, right? And then we can simply do a negative of I minus 1 plus 1, right? Remember, so the difference has to be alternate. That's why the first one has to be the negative 1 plus 1, right? And similarly for this one has to be a positive I minus 1 plus 1, right? So in the end, we can always simply use this one again. So if I run the code here, oh sorry, so this is I minus 1, right? Yeah, so it works, right? So this one, as you guys can see, it's obviously a O of n time complexity, right? And so the space is still of n, right? But since this one only relies on the previously I minus 1 state, we can easily compress it to a O of 1 space complexity, which means that we just do this, right? Positive equals to 1, right? And then we have negative equals to 1. So here, similarly, right? If you guys remember, we have the negative 2, and then we have a positive sign to this one, right? And then we have this positive 2 equals to negative plus 1, right? And then here is a negative 2 equals to the positive plus 1, right? In the end, we do this. We do a pos equals to pos 2, and then neg equals to a neg 2, right? In the end, we simply return this to the biggest values between those two values, right? Yeah, this should also work, right? So now the space complexity is all of 1. I think this part basically I'm just replacing the variables here. Maybe we don't have to do these things here, and yeah, actually this one is not necessary because we have this. No, okay, we still need this too because it could go into one of the if statement. right? Not both. So that's why we need to set these two things regardless. Cool. Yeah, I think that's it, right, for this problem. No, this is like a little bit of variation of the LIS, but actually it's a little bit simpler than that one because um, in the end, right, all we care is the current I and the I minus one numbers, right? So from those two numbers, we can easily accumulate the positive subsequence, the longest subsequence who has the positive as the last difference, right, or the negative difference. And then in the end, we just need to get the maximum between those two values. Cool. I think I'll just stop here and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.